Okay, so today what we're going to do is we're going to continue our practice with solving problems with mole ratios. So I'm going to do some practice problems up here on the screen before you guys start your next activity. So let's take a look at some examples of solving mole ratio practice problems. Okay, so here's our first equation. Calcium plus oxygen reacts to make calcium oxide. So the first thing we want to do is make sure that we have a balanced chemical equation. So there's no coefficients in here, so it's probably not balanced. So let's take a look and balance the equation. So we can see we've got 1 calcium on the left and we've got 1 calcium on the right, so that's balanced. Right, and we've got 2 oxygen on the left and only 1 on the right. So that means we're going to need to put a 2 out front here, right, to balance out that oxygen. But now we've got 2 calcium on the right now, and so to balance that out, we need to have a 2 out front here. So now we've got 2 calciums on both sides, and we have 2 oxygen atoms on both sides. All right, and so remember that these coefficients that we just changed are representative of moles of that substance. So in this reaction, we could say 2 moles, right, of calcium plus 1 mole of oxygen is going to react to form 2 moles of calcium oxide. All right, and remember, a mole is just equal to that number 6.02 times 10 to the 23rd. Right? So it's just a counting number like dozen or pair. In fact, we could say 2 dozen calcium atoms plus 1 dozen oxygen atoms is going to equal 2 dozen calcium oxide molecules. All right, so it's just a word. Okay, that means a number. All right, so now that we've got this balanced, our question is, how many moles of calcium oxide are produced when 3.7 moles of oxygen are used? All right, so what we need to do is kind of first, identify what we're given and what we need to find, right? So we have to look for keywords in our question. Here's the keywords to figure out what we're going to find. We're going to find, it says how many moles, right? So that's kind of the keywords that you're going to be solving for moles of calcium oxide. So basically, calcium oxide is going to be our X. Okay, X number of calcium oxide moles. And then are produced when, here's our number here, right? We've got 3.7 moles of oxygen. Okay, so this is what we're going to start with, 3.7 moles of oxygen. Let's grab a different color. So 3.7 moles of oxygen. So basically we're starting with 3.7 moles instead of 1 mole. So in the original recipe, right, we've got 1 mole of oxygen reacting. When it reacts, it can form 2 moles of calcium oxide. Okay, but here, now we're starting with different ingredients. We're not starting with 1 mole, we're starting with 3.7 moles. Okay, so what we're going to do is we're going to use the ratio from the recipe, though, to figure out how many moles of calcium oxide we can make. Okay, so our ratio between oxygen to calcium oxide is what? In the recipe, it's 1 to 2. Right? Because oxygen has a coefficient of 1 and calcium oxide has the coefficient of 2. So we have a 1 to 2 ratio. So what that means is that the calcium oxide is always double, right? This guy is always double the amount of oxygen. So however much oxygen we have, we can always make double the amount of calcium oxide. Okay, so we got to just keep that in mind. Whatever we have for oxygen, we're going to make double of in calcium oxide. So, in this particular question, we are given 3.7 moles of oxygen to work with. Right? So, if we know that calcium oxide, it's a 1 to 2 ratio, that means that we are just going to double our 3.7, and that's going to be the number of moles of calcium oxide we can use. So 3.7 times 2 is 7.4. So 7.4 moles of calcium oxide can be made if we have 3.7 moles of oxygen to start with. Okay, so that's the whole idea behind mole ratios, is just to use the ratio to figure out which, is it doubled, is it cut in half, is it tripled, is it a third, is it a fourth. We just use those in order to solve for those problems. Okay, so mole ratios are just ratios we can use to figure out, if we start out with something else, how much we can make in the end. All right, let's take a look at our second equation. Our second equation is gallium iodide with reacting with sodium chloride to make sodium iodide and gallium chloride. Okay, so again, the first thing we always want to do is make sure that it's a balanced chemical equation. So go ahead and write this down in your notebooks and take a minute to balance it. And then we'll come back and make sure that you guys did it right. So let's pause the video there and balance the equation so you can see if, and we'll check to see if you did it right. All right, so you should have the coefficients 3 in front of the NaCl and 3 in front of NaI. Okay, so the coefficients are 1, 3, 3, and 1. All right, so now that we've got a balanced chemical equation, let's take a look at the question that is being asked. It says, how many moles of gallium chloride are produced when 0.75 moles of sodium chloride are used? Okay, so here we're trying to figure out how much gallium chloride, how many moles of gallium chloride are produced when instead of 3 moles, we're actually starting with 0.75 moles. Okay, so according to our recipe, what's the ratio of sodium chloride to gallium chloride? Okay, our ratio here is, well, we look at the coefficients, right? We have a 3 in front of the NaCl and we have a 1 in front of gallium chloride. So our ratio is a 3:1 ratio. This means that for anything that we start with, okay, sodium chloride will always be triple the amount of gallium chloride, always, because it's a 3:1 ratio. So whatever we have with gallium chloride, sodium chloride will always be triple the amount. Okay, so in this case, though, we are given the amount of sodium chloride as 0.75 moles, right? So if sodium chloride is always triple the amount of gallium chloride, okay, then what we need to do is we need to divide this by 3 so that we can get, basically the smaller number. So to go from sodium chloride to gallium chloride, we need to divide it by 3 so we can get the smaller number in the ratio. So we're going to divide this by 3, and we do 0.75 divided by 3 is 0.25. Okay, so have 0.25 moles of gallium chloride. Okay, so that's how we can just kind of look at the ratios and figure out what to do. Now, some people understand that we can actually put together proportionality equations with this in order to solve the problem. So I'm going to show you with this one how you can create a proportion and cross multiply in order to get the answer as well. So then what you can do is we'll have one more question that I'll go over both ways, and then you pick whatever works best for you. If you can see it with just the ratios and the numbers, fabulous. Okay, but if you have to put it into a proportionality equation, then do that as well. Okay, so in our proportionality equation, or method in order to solve this, we're still going to use the ratios, because remember, proportions are ratios. So if we know that the ratio between sodium chloride and gallium chloride is 3:1, instead of doing it like, the little colon format over here, what we're going to do is we're going to put 3 moles of sodium chloride, and we're going to do it in a fraction instead. And then over 1 mole, right, of gallium chloride. And so whatever we put on this side has to be equal to each other. So that's what a proportion is. It's two ratios that are equal to each other. And so to set this up, we'd have to make sure that we have our moles of sodium chloride on top and our moles of gallium chloride on the bottom, right, of our ratio. And here on the other side is where we put what we're given in the equation, right, or in the question. So here we're going to put our moles of moles of sodium chloride. So 0.75 is going to be on the top. And then our moles of gallium chloride is what we need to figure out. So that's going to be our X. So here we've got the proportionality constant or proportionality equation of 3/1 equals 0.75 over X. And so what we can do is just cross multiply, right? So 0.75 times 1 is 0.75. And that's going to equal 3 times X. And then if we divide both sides by 3, boom, we get the exact same thing as we did over here, 0.25, okay, moles of gallium chloride. All right, so use whichever way works for you. I know in math you've learned about ratios and you've learned about putting it into proportions. And so use whichever one that works for you as long as you understand what's going on. Okay, let's take a look at one more problem. All right, here's our last and final example for today before you guys get onto your assignment. So here we've got the chemical equation for making ammonia. So we've got nitrogen gas and hydrogen gas coming together to form ammonia. All right, so again, the first thing is always to make sure that we have a balanced chemical equation. In this case, it's not balanced. Okay, we can take a look and we see we've got 2 N's on the left and 1 N on the right. We have 2 H's on the left and 3 H's on the right, so this is not going to work. So again, write this down in your notes and then pause the video so that you can balance the equation. All right, so to properly balance the equation, you should have put a 2 in front of ammonia and then a 3 in front of hydrogen, right? So we've got 2 nitrogens on both sides and we have 6 hydrogens on both sides, all right? And so our ratio, our moles are 1, 3, 2. All right, so now that we've got a balanced chemical equation, let's take a look at the question that's being asked. Okay, it says how many moles of hydrogen, okay, that's our H2. So how many moles of hydrogen, that's our X, are needed to produce 17 moles of ammonia. So now we are not, instead of working with 2 moles like our recipe says, now we're going to be making 17 moles. So we need to figure out how much hydrogen we need to use. Okay. All right, so let's take a look at the ratio between hydrogen, right, and ammonia. Okay, hydrogen has 3 moles and ammonia has 2 moles. Okay, so it's a 3:2 ratio. All the other ones we have been worked with before is a 1 to something. So those are much easier to work with. Could you say, hey, that's double, or hey, that's triple, right? It's a nice whole number. This one isn't going to be a nice whole number, okay? So what you can do, okay, is realize that, okay, this is like a 1 to 1.5. So, hydrogen is always going to be 1.5 times the amount of nitrogen, right? So what we would do is if we're given the 17 moles of ammonia, and hydrogen is always 1.5 times it, then we have to do 17, right, times 1.5. So if we do that math, we're going to get 25.5 moles of H2. Okay, in the end. So that's going to be our answer right there, 25.5 moles of H2. Okay, so this one, you could kind of realize that a 3:2 ratio could be reduced down 1 to 1.5, and so if you know you have 17 moles of ammonia, then hydrogen is always 1.5 times more. Okay, so then you would end up with 25.5 moles of hydrogen. But let's take a look at the same question doing the proportion way. So again, we need to use the ratio. We always use the ratio when we're working with moles from one thing in the reaction to moles of another. And so we've got 3 moles of hydrogen, okay, for every 2 moles of ammonia. All right, and in order to solve for the number of hydrogen moles in the end, we need to make sure that we've got the same units on the top and the bottom. So we started with H2 on the top, so we're going to have moles of H2 on the top here, and we have moles of NH3 in the bottom, so we're going to put moles of NH3 on the bottom as well, and then we're going to fill it in with what we know from the question. So the question has asked us how many moles of hydrogen, so that's our X on top. And then we've got 17 moles of ammonia, and that's going to be on the bottom. And so we've got 3 over 2 equals X over 17. And in this case, again, we can cross multiply. So 2 times X is 2X. And 17 times 3 is 51. Right? So we got 51 on this side. 3 times 17 is 51. So when we divide by 2, okay, we're going to get X equals, and again, 25.5, right, moles of H2. 25.5 moles of H2. Okay, is going to be our answer for this one. So we did it using the ratios here on the right-hand side, and we've done it using the proportions on, the ratios on the left-hand side and the proportions on the right-hand side. So again, use whichever way you makes sense to you, all right? And we're going to do some more practice with this in the assignment today.